Okay, so as we've seen, we've got a bit of a fire and ice theme going. Let's see if we can combine the two. So, who's tried to light a fire out in the woods when it's cold and it's snowing? Yeah, you have? It's good. There's not much snow in Australia, so... Okay, what if I told you that you didn't need any wood, just snow? Alright, so we're going to try and make a burning snowball. Firstly, we need to make some snow. Alright, so I've got 2 clear liquids here. And there we go. Now we have some snow. Alright, now we'll make this into a snowball. Make a nice big snowball. Alright, there we have it, a snowball. Now I'll ask Horst to light the snowball for me. And there you have it, a burning snowball. Alright, so what I did there was I added some ethanol into a salt solution, and this caused it to form a gel. Now these sorts of gels are at the forefront of current research because of their weird and wonderful properties. Like this, it's a wet thing that's dry. It's weird, makes them very, very interesting. Let's try and put this out. Horst? Yakov? All right.
Now, it isn't only chemists who get to burn things. Sometimes we physicists do as well. Right? And we have the most flammable substance in the room here ready to be burned. It is home brand cornflour. Now, very, very flammable stuff. What I'm going to do is this. I'm going to put a pile in my hand, and taking my life and limb at risk for your entertainment, I will set it on fire. Who wants to see me endanger myself? Don't applaud, just throw money. Okay, here we go. We're going to set this on fire. Did that set on fire? No. Any idea why not? There are a couple of really budding pyrotechnics in the front rows. I've seen them. Why isn't this catching on fire? It's not your popular fake flour. It's real flour. Yeah, what do you think? Yeah, was that what you were going to say as well? Yes, it's not got any oxygen. Fire needs 3 things, all right, to catch on fire and light. Fuel, we have fuel. Flame, we have flame. Oxygen. We have a very technical device that is built to put a lot of oxygen into cornflour. From the people who bought you the breathable air gasometer, it is the funnel with attached piece of tube. Right. So, funnel. Into my funnel, I'm going to load the cornflour. Bit more. Yeah. Now, instead of the lighter, we're going to use Mr. Blowtorch. Right. Now, who wants to see me endanger myself again? Okay, but I would like your help. I would like you to clap, slowly, getting faster and faster, until you cannot hear me setting off the fire alarm. Lights, please. Faster, yeah. Again? Yes! More cornflour. All right, but you have to learn something from this, okay? Oh, I've never used this much before. We'll see how it goes. Okay. Once more. Clap. You have to take something away from this. Flour factories. Back in the Middle Ages, you weren't allowed to work in flour factories at night. Because if you took an open flame into a flour factory, all the small flour that was being ground up floated around in the air and could catch on fire.
Very nice. We had the physicists with fire and burning flour. And we heard already that that has some real-world implications because it's hard to put out a flour fire in a mill overnight. Now we're going to do some fire that is burning in ice, not just in a snowball, but in real-world ice. I've got here 2 blocks of ice, and they aren't just any blocks of ice, they are dry ice. Does anyone know what dry ice actually is? Just yell. Carbon dioxide, right. And what is carbon dioxide? It's the gas that we all breathe out. And we breathe it out because we would asphyxiate. It's the gas that we cannot use. It's also the gas that's in these nifty little implements and that is used to put out a fire in a fire extinguisher. So what I'm saying is I'm going to light a fire in solid carbon dioxide and it will burn, and it will burn like crazy. The reason why that is so dangerous is because we cannot put it out with a carbon dioxide extinguisher. Now, what is this wonder substance? It's magnesium. Magnesium is one of those really lightweight metals that's used in all kinds of technical applications. For example, airplanes. Because it is very light, if you make a hull of an airplane out of magnesium, the airplane is light and doesn't weigh so much on takeoff. But that is highly dangerous. I'll use a little bit more. So we've got a decent heap of magnesium in here. And now we're going to light the whole thing. So a warning though. As soon as I light the magnesium, it will burn very, very brightly. Do not look directly into the flame. If you want to see what's going on, look over to the screen. Once I put the second block on, then you can start looking directly. So you see a couple of sparks flying there. I just need to heat up the magnesium until it starts reacting. There we go. And now I put the second block of dry ice on. And now we've got a fire of magnesium that burns inside a solid block of dry ice. What is happening is that the magnesium is reacting directly with the carbon dioxide, and you basically get elemental carbon left. So this fire can just burn and burn and burn, and we can actually not put it out, except with some very special implements that we have here. But it looks very, very pretty, so we just let it burn. It's a really cool way to keep your house alight at night. Although I wouldn't do it. And look, fireworks, and it sparks. So eventually all the magnesium will have reacted and we will have just a solid lump of charcoal left. And that's the point when the whole dry ice dims down and the reaction finally stops. So there you have it. Burning, shining, dry ice.
So I got a question for you. Who here likes to make noise? You're not very convincing. Who here likes to make noise? Much better. All right, I have a special device here, perfect for making noise. It is called the Balloon-Orientated Noise Gadget. Now, I'm sure the grown-ups are wondering what inspired this. I'm not sure the design. I believe it comes from some art students, though. Now, all I have to do is I put a balloon over this open nozzle, and then I'm going to tie it on really tight. Then fill the bottle with liquid nitrogen and seal the lid. I'm sure you can all imagine what's going to happen. All right. Do you want to grab the plate? So, I'm not going to put much in. So remember, how much is 1 cup going to fill? About a bathtub, that's right. I seal the lid and we see it starting to inflate the balloon. That's going along quite nicely, but we want to speed this reaction up, so we need to heat it. I've got here just a plate of water, and compared to the liquid nitrogen, the water is really hot, so it's going to help speed the reaction along quite nicely. Okay, everybody ready? Right, 3, 2, 1. Uh-oh. So this is the largest piece of the balloon that's left, and as we can see, it's completely torn to shreds. Not bad, eh? All right, and I guess we're on to our finale.
How else could we started the show with a bang? How else could we finish the show but with a really, really big bang and with a really, really big fireball? We've got a really special experiment. It's called the barking dogs of hell. Now, seeing as we're university and not industry, we don't have that much money, so we have got only one barking dog. And you can't actually see it because we trapped it in this tube of glass. But you will be able to hear it. And it's going to make a mighty, mighty large bark. Now, since hell is actually a dimension separate to our normal world, we have to coax the dog of hell to come into this dimension. So what we got in here is something that every dog of hell loves, laughing gas. Because even though they're from hell, they like a good laugh. Now, what else do barking dogs from hell like? Sulfur and brimstone. So here we've got a little bit of liquid sulfur. That Yakov is going to squirt into the trap for the hellhound. And we close this up again. And now I just shake this around so that the hellhound can have some inducement of coming into this dimension. And now all that Kirsten is going to do is lighting this, and beware, the bark is loud. The barking dog of hell. And what had is left behind? It shed sulfur all over the tube. Bad dog. Ladies and gentlemen, this is the end of the show. Thank you very much for coming here today. We hope you had a lovely time at the show. We hope you will continue to have a lovely time here at the UQ. If you're thinking, wow, this science was so cool, I want to go into science, go do it, follow your dreams. Thank you very much, and see you again.